I am Raja SHYAM from Chennai. We run a firm called PTK Project Consultants LLP. We have two verticals. One is industrial and the other one is universities and educational structures. Today I am here to talk about steel design in one of our university projects. This is SRM Campus at Amaravati. That is the erstwhile supposed to be the capital of Andhra Pradesh. Now we don't know what is the status of the capital of Andhra Pradesh. But SRM wanted to put up a huge university there, a 200-acre campus. And we went and selected the site for the clients. And for the master planning expertise, we had partnered with Perkins & Will, Chicago. But we could not wait for the master plan to be brought out. So we had to immediately start the university within a year or less than a year. So we had to take away about 14, 15 acres in one corner and start the construction. That was done immediately while the master plan was on. This is the total master plan, of which the northeast, the right-hand top corner is the 14-acre property that was earmarked for the initial launch campus, and we had to start construction of it within no time. As we had visited the site along with the client, it was a complete barren land and there were a bunch of trees. And because it was very sunny and we could not walk the entire 200 acres, myself and my client and a couple of their representatives, we had to go under a tree and then stand there and imagine our university there. At that time, we had a small discussion about how olden days gurus used to sit under a banyan tree and impart knowledge, but we needed thousands of crores nowadays to build an university. And when we came back to the drawing board of this 14 acres, we had a big challenge in front of us, 6 lakh square feet in 7 months' time. Sarpuji Palanji was the main civil contractor, and all of us knew that it is going to be a tall order to build the whole thing. Even the clients knew about it, but they had to start. There was a political pressure for them to start. So I remembered this little conversation with my client about this banyan tree and all that. Then I proposed this, can I build a banyan tree for you? As the buildings are being built, this tree can be built in steel in no time. And if at all there is a lag in construction, we can do 1 or 2 blocks, complete them and launch the university. And that's how this was frozen. So when you see the form development, that was the main form, split into 3 different buildings and interlinked with bridges. All this was done for ease of construction and making it as quick as possible. So we could do 1 building this side, 2 buildings that side, and then interconnect them. And the whole roof, if you see at the bottom, the roof could cover this entire building. This roof itself was about 50,000 square feet, and it could be constructed independent of these structures. Actually, steel saved the day for us, and we could launch the project in 7 months' time. So this is how it would look, the main building with the steel pavilion on top and this cluster of buildings below this. The steel pavilion also allowed us, in the program, it was not just classrooms and laboratories and administration spaces. The program was very strong with teacher-to-student interaction, student-to-student interaction. Actually, any university design starts with contact time between a teacher and a student. Here we had this program very specifically as a contact time between student and student and teacher also. So we had to accommodate that within the program and deliver this. This is how one of the sides look, the pavilion as such, with these buildings floating below. This is the other side. This is from the other side. So this is the concept that was discussed with the client. If you see a large banyan tree and some buildings at the bottom, split these buildings into 3 different blocks. How to get the banyan tree with the steel roof was the main challenge for us. This particular roof is hovering at around 30 meters height. This is a regular process drawing for architects. This is the steel GA drawing, and we did this entire pavilion of 50,000 square feet with just 28 columns. This is about 165 meters by 30 meters in the overall sizes. And as I told you earlier, there was 1 block at that point. There are 2 blocks happening here, and the bridges were connecting these 2. And when I could remove some of these terraces, I could get a lot of interaction spaces, some library spaces. Everything happened because of this pavilion that would come on top. It was not easy to convince the client to spend about 12-13 crores for a pavilion, but the steel and its speed allowed me to convince the client. This is some of the cross sections that we normally do to show you how the pavilion is floating above these RCC buildings. Some of these steel structure had to be integrated with RCC, and some of them were totally independent. They were plain, simple steel columns that were from the bottom till the top, 30 meters of freestanding columns. Here I would like to acknowledge Srinidhi Anantaraman of Geodesic, who designed this beautiful pavilion for me, and he could execute it in no time. Plus, there were a lot of demands from me. Say, for example, there are these ties that anchors itself into your RCC structures, but whereas there are about 8 columns where I did not allow any kind of tie. So he was very accommodative in redesigning, designing, redesigning, but still achieve the whole thing within that stipulated time. So this is how the conceptual pavilion structural drawing looks like. And this is how each pod was erected at site. It was a beautiful scene to see at site. Only 2 or 3 people standing and assembling the pod, and 1 crane operator at this point. When it is lifted up, sometimes it would fail, sometimes they would reassemble the whole thing, and by the time it goes on top, they are there with in another place running up and staying there to fix these. It was done, about 3 people were there at site and 1 supervisor and crane operator. Very safely done, very quickly assembled. From the beginning, there was an issue with the design that we had to get this feel and form with a false ceiling at the bottom. And the false ceiling with Hunter Douglas, we were discussing with Hunter Douglas for quite some time. It was crossing 4 crores, and we didn't see a point of having so much money to be put in only for false ceiling. So again, Srinidhi and myself, we came up with this sheet being put at the bottom rather than on the top, and solving the entire rainwater issue. Once we solved the rainwater issue, we saved about 4 crores on the project. This is how it was assembled at site. Stage-wise, I have to thank KPMG to have sent us weekly reports. I could pick up these from them. And this is that central single pillar without any tie or any kind of bracing that is standing, about 4 plus 4, 4 of them, which was erected in the end so that the forces could be transferred to the nearby pods. So this is how it looked before the sheets were up. This is how it looked after the sheets were done, and then there was a screed concrete on top, and there was a complete painting done from the bottom. So as you see this is how the building started functioning, and it was functioning very beautifully as the construction was going on. We had lot of students and teachers on one side of the block. Their classrooms were on, their labs were on, but the construction was going on this side. So this is the final stages of construction. We could even get a complete covered terraces, couple of terraces for the library because of this pavilion. There's another construction site. Here we had a lot of simulations for ventilation. The air that comes in had to go out, so we did a lot of simulations so that the place below is kept very comfortable for children. Today we see that a lot of activities like photography exhibitions and even shuttle tournaments are happening in the atrium spaces below. This is one of the interior spaces where the structure is exposed, and Hunter Douglas had done the ceiling below. That is the library there. And the water supply, how the water was taken through the columns and taken out is shown in these drawings. This is how it was finished finally. There was a huge dining space that could happen because of this pavilion in the building itself. This is the most wanted space. If we go now, there will be no space for us to sit. You could actually see 10 of them sitting in one table nowadays. This is how it looks finally. The inside spaces where the steel building is exposed, where it is covered, where there is false ceiling and it is covered. And this is how the total building campus itself looks like. And they had a photography exhibition, and the Vice Chancellor called me and said, "Shyam, your steel pavilion has got 90% of the photographs by the children. They liked it so much. And they have taken photographs of this building when the sun was rising, sun was setting. And this is how it looks." Yeah. Coming to the end of my presentation, I have to thank Mr. Srinidhi Anantaraman, who did the complete pavilion design, was his, along with me, of course, and Paramayan from Bureau Engineers did the complete RCC and integrated the steel into the RCC. Thanking the entire team, I will close my presentation.